Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever with the great band ELO, Turn to Stone. Today we are talking binomial coefficient, the binomial coefficient. So let's get to it, shall we? Okay, so the binomial coefficient has a connection with Pascal's triangle, as indicated somewhat by this graphic, and we're not going to get to that just yet, but we will get to it in our next lesson. So, factorial notation, what is that? Well, that's a way to multiply consecutive decreasing integers. It is notated by n factorial, where n is an integer greater than or equal to 1. And it's simply n times n minus 1 times n minus 2, blah, 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 all the way down to 1. For example, 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, whatever that product is. So 8 times 7 times 6 could be written as 8 factorial over 5 factorial divided by 5 factorial. Because if you list those out, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, 5 factorial is 5 times 4 times 3 times 2 times 1. Well, the numbers in red, the 5 times 4 times 3 times 2 times 1, cancel out because the same thing over the same thing is equal to 1, and multiplication by 1 gives you the original factor. The factorial rule shows us that we define 0 factorial as 1. So by definition, 0 factorial is equal to 1 whenever we encounter it. All right, so let's try this out. We have got A, 4 factorial. Hopefully, you've got that already done in your head. 4 factorial is simply equal to 4 times 3 times 2 times 1, which is 24. 12 times 2 is 24 times 1 is 24. So B, I'm going to show you what's actually happening, and then I'm going to show you how I want you to think about it. So 5 factorial is 5 times 4 times 3 times 2 times 1 over 3 factorial, which is 3 times 2 times 1. Well, 3 times 2 times 1 is the same as 3 times 2 times 1. Since it's multiplication, we can cancel. Since it's the same thing over the same thing, it's equal to 1. So this is really equal to 5 times 4 times 1, or 5 times 4, which is 20. And then C, we can do, oh no, hold on one second. What I would like you to do is observe 5 factorial over 3 factorial. That's immediately equal to 5 times 4. Because of this, I can, if I have a greater factorial divided by a lesser factorial, the lesser part is going to cancel out and the greater part up in the numerator. So the 3 times the 2 times the 1 is going to cancel out. So we should quickly realize that's simply 5 times 4, or 20. That's very helpful for this because we can think of this as, 4 factorial, well, 4 factorial times 3 factorial. You always want to cancel out with the greatest factorial as possible in the numerator, or I'm sorry, in the denominator. So this term, if I think of 4 factorial and get rid of 4 times 3 times 2 times 1 from the 7 factorial, I'm left with 7 times 6 times 5, because the 4 factorial cancels out. So I'm done with that. And this is now over 3 factorial, which is 3 times 2 times 1. And here's a quick way to cancel. I've got a 6 here, and I know that 3 times 2 is equal to 6. So instead of doing the 3 and then the 2, I can just cancel it out all at once, because it's equal to 1. I like to write the big 1 here. It's just a 1 there. Oops, that's an arrow. 1, whatever. 7 times 1 times 5 over 1 is really 7 times 5, which is 35. So we need factorials in order to be able to find the binomial coefficient. So NR is read n choose r, and I'm just going to put combination here. We'll get back to that in a second. It is a combination in probability. So n choose r. In addition to writing it this way, you'll also see it written this way, n choose r. And it is equal to this by the definition of factorials. So in the end, n choose r, and this is in your formula booklet, is equal to n factorial over r factorial times n minus r factorial. And I'll explain the choose thing right now. So let's say I had the 5 letters A, B, C, D, E, and I was going to arrange them in as many groups of 2 as possible. We would call that, or one way we can think of this is 5 choose 2. 5 choose 2. 5 letters, let's choose as many groups of 2 as possible. And that's what this means right here. So by our formula, 5 choose 2 is equal to, now this is my n is 5 and my r is 2. So that would be 5 factorial over r is 2, 2 factorial, 5 minus 2 factorial. And again, I'm just using this formula right here. So this would be equal to 5 factorial over 2 factorial times 3 factorial. And by the way, let me just show you something real quick. So 5 factorial. 3 factorial, no, that's a 2, sorry. 2 factorial times 3 factorial. We can write it like that without any multiplication symbol in between, and it still indicates multiplication. All right, so like we said before, with the 3 factorial here, 5 factorial becomes 5 times 4. So that's gone, and now I've rewritten this cancellation as 5 times 4. Over 2 times 1, 20 over 2 is equal to 10. Okay, so what's the significance here? Why do we call this 5 choose 2? And it equals 10. Well, guess what? Whenever you have a group of 5 arranged in a combination, in combinations of 2, the result is going to be 10 distinct groups. 10 distinct groups. So we can quickly, using the binomial coefficient, we can find out how many possible combinations there are given any sort of option. And remember, with combinations, AB is the same as BA. So that's why you don't see a BA here, because AB is already there. It's the same thing. So you don't list it twice. All right, so for B, we have 11 choose 7. So that means if I had a group of 11 letters, A, B, C, D, E, F, G, H, I, J, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, K, 11, and I wanted to arrange them in groups of 7, say A, B, C, D, E, F, and G, that would be the first group of 7. If I wanted to know how many how many groups of 7 there were out of 11, how many different combinations, I could list them all, or I can use the binomial coefficient. So this would be 11 factorial over 7 factorial times 11 minus 7 factorial. And you don't have to write that every time. You can certainly do it in your head. So that would be 11 factorial over 7 factorial times 4 factorial. Canceling out the 7 factorial with part of the 11 factorial, we're left with 11 times 10 times 9 times 8. So that's gone, over 4 times 3 times 2 times 1. And I'm going to intelligently cancel out 4 times 2 with 8, so those are gone. and then the 3 becomes a 1, and the 9 becomes a 3 with simplification. I have 1 in my denominator, so I have 11 times 10 times 3. Well, 11 times 10 is 110 times 3 is equal to 330. Okay? Well, that means if I listed all the possible groups of 7 from 11 letters or 11 objects, doesn't have to be letters, obviously, hopefully, obviously, there would be 330 different groups of 7. Okay, so those we could do by hand, but sometimes they're large and we can't, or even if we can, if we have a calculator available to us, we should use it. So first we'll do 5 choose 2, and to get to the choose function on the Inspire, a couple ways to do it. Menu, it is probability, because it is a combination, and we get NCR, so we just type in 5, comma, 2, enter, and we get 10, which is what we got before by hand. 5 choose 2 is 10 right there. 11 choose 7 is 330, so let's just do that. And the other way you can do it, if you remember N choose R, NCR, you just type in N, C, and notice how the font is italicized right now. But once I type in the R, the calculator recognizes it as the choose. And choose R, you have to type in your own parentheses, 11, 7, enter, and we get the 330. So let me paste that in your notes. And through the miracle of technology, there it is. 5 choose 2 is 10, just like we did here. And 11 choose 7 is 330, just like we got right here. All right, I am good. Hope you enjoyed it. I know that I did. And we will finish with some more ELO and turn to stone. And with that, I am out.